Today we're going to talk about verifying identities. And I'd like to put a few ground rules in place first. Verifying identities are like doing geometric proofs. So technically, we should have statements and reasons, and every step should be justified by a reason. I want you to keep those reasons in your mind, but keep in mind that if going from one step to the next, I can't obviously see what reason you were using, then I'm going to make deductions on your identities, your proofs. Okay, the other rule is you must pick one side of the identity and prove that you can make it look like the other side through substituting of our basic trig identities or various algebraic maneuvers or strokes of pure genius. No magic is allowed. Okay, so I've got some to show you how this works. So we have secant squared of pi over 2 minus x minus 1 equals cotangent squared of x. I either have to pick the left side and make it look like the right side, or pick the right side and make it look like the left side. I think I have more to play with on the left side, so I'm going to pick the left side. And I need to make my work flow beneath the left side. So secant squared of pi over 2 minus x, I'm going to say that's an immediate replacement, and it gets replaced with cosecant squared of x minus 1. I will not write this right-hand side again until I've made the left-hand side look like it, so don't write anything here. We're not working with that side. Cosecant squared of x minus 1 is a piece of a Pythagorean identity. So I'm going to use a Pythagorean identity to call that cotangent squared of x, and I am done. If by chance you wonder what it would have looked like with the reasons written in, the reason that I came from step 1 to step 2 would have been a co-function identity. And the step that made me go from step 2 to step 3 was a Pythagorean identity. We will not be writing these in, but as often as I can remember them, I will say what I'm doing, and in your mind, you should as well. Say what you're doing. Okay, problem number 2. Again, I see more to work with on the left side. I can only do one step, one reason. So the first thing I'm going to do is I'm going to take out cosine of pi over 2 minus x using a cofunction identity and call that sine of x. Cosine of negative x will have to hold for a moment. So my reason was cofunction identity. Now I'm going to use the even and odd identities to say that sine of x stays, but cosine of negative x by the even and odd identities is just cosine of x. And by the quotient identity, sine of x over cosine of x is tangent of x. Hey, look, that's what I was aiming for. Tangent of x. This particular problem, I could start on either side. They're both really interesting. I'm going to assume that most of you would start on the left and find a common denominator. And I want to show you a different technique, but I too would probably start on the left and find a common denominator. But if I decided to start on the right, I would use that technique that says a Pythagorean identity sometimes goes smaller, but it sometimes goes bigger. So secant squared of beta would be tangent squared of beta plus 1 over tangent of beta using a Pythagorean identity. If I have a monomial denominator, well, it doesn't matter what my denominator is. I can break my numerator so that each term in my numerator is over that denominator. So this would say tangent squared beta over tangent beta plus 1 over tangent beta. That's just by, you might call it like reverse addition of fractions. This particular fraction can be simplified. So it would just be tangent of beta plus 1 over tangent of beta. You might say you're done, and I would say you're not, because the right-hand side doesn't look exactly like the left. I have to take one more step using the commutative property of addition to say that this is the same as 1 over tangent beta plus tangent beta. Now I'm done. Okay. Again, this is another one where either the left side or the right side will suffice. I'm gonna go with the right side because I want to show you as many tricks that are up my sleeve as I possibly can. 2 cosine squared theta is like cosine squared theta plus cosine squared theta, right? Because I would call that, what would I give as a reason for that? I would call that undoing like terms, separating like terms. And cosine squared theta minus 1, well, the identity says sine squared theta plus cosine squared theta equals 1. So cosine squared theta minus 1 is actually negative sine squared theta. So by a Pythagorean identity, cosine squared theta minus 1 is negative sine squared theta. Oh, I'm actually done. I'm guessing. I'm going to start this one again because I'm guessing you probably would not have done that. So let me erase that. Okay, I'm guessing you might have said maybe cosine squared theta. No, let's see. This side doesn't have sine squared theta, so I want to get rid of sine squared theta. So maybe I replace it with 1 minus cosine squared theta. So you might have gone this way, cosine squared theta minus, in a parenthesis, 1 minus cosine squared theta. Right? This is a Pythagorean. And then I would distribute my negative, cosine squared theta minus 1 plus cosine squared theta. And then I would collect my like terms, 2 cosine squared theta minus 1, and I would be done. I'm guessing that probably felt a little better. And probably it does. It is. Okay. I'm definitely starting on the left. I'm going to replace tangent with the quotient sine x over cosine x. So cosine x plus sine x times sine x over cosine x. I'm going to follow the order of operations, I guess. Cosine x plus sine squared x over cosine x. Now I'm going to find a common denominator, so I'm going to multiply this by cosine x over cosine x. So I'm going to get cosine squared x plus sine squared x. And by a Pythagorean identity, that's 1 over cosine x. Now I'm going to peek back. What am I aiming for? Let's see. Oh, I'm trying to be, hey, I'm trying to be secant x. Excellent, and now I am. Okay. I am going to use that technique that I showed you a little earlier and say every term in the numerator could be over that common denominator. So kind of like unadding. So I'm going to get cosine squared x over sine squared x minus sine squared x over sine squared x. In my next step, I'm gonna use the fact that sine squared x over itself is 1. I cannot simultaneously do anything with this, so I'm leaving that alone. Right? Because my reason is anything divided by itself is 1. Okay, now in the next step, I'm going to say that that is cotangent squared x. What in the world am I shooting for? Negative cosecant. Okay, so the Pythagorean identity goes 1 plus cotangent squared theta equals secant squared theta. So cotangent squared, no, cosecant squared theta. I have a mess here. Okay, cancel this problem. I think I have a copy error. All right, see you tomorrow.